Hello everyone, I hope you guys doing good. Today I'm here to discuss on a small topic called Reynolds number. What is a Reynolds number? Reynolds number is a ratio of internal force to the cell viscous force. The formula of Reynolds number is NRE is equals to du rho by mu, where d is equals to diameter of the glass tube, u is equals to velocity of the fluid flow, rho is equals to density of the fluid, and mu is equals to dynamic viscosity. And now we are going to discuss about Reynolds apparatus. Reynolds apparatus consist of dye tank, constant head tank, small tank, valve, glass tube, filaments of dye, regulating valve. Why it is called as constant head tank? When the water flows into the glass tube, then the head of the water is going to be constant. That is why we say it as constant head tank. The second tube that we can observe is dye tank. It can also be called as dye container. The blank line that we can observe in the glass tube is called as filament tube. And next we can observe a regulating valve. It regulates the water, and the another valve which regulates the flow of dye. Experimentally, when the head tank attains steady state, we open the valve slowly and we also open the regulating valve. Then the dye flows from the valve through the glass tube and it comes in contact with water. When we talk about the main purpose of Reynolds number is to illustrate the laminar, transitional and turbulent flow and to determine the conditions under which this type of flow occurs. And now we are going to talk about observations by Reynolds number. In the previous slide, we have observed the main purpose of Reynolds experiment, that it illustrates the laminar, transitional and turbulent flow and also determines the conditions under which these types of flow occurs. So in this slide, we'll take a brief explanation about a laminar, transition and turbulent flow. So laminar flow, when the velocity was low, a fine filament of dye was carried by the following water into a straight line. The dye filaments was moving at a straight line path. This state is called as laminar flow. So in laminar flow, the filaments move in a straight line path. Next, transitional flow. As the velocity increases, the dye filaments become wavy and irregular. Now it doesn't maintain the straight line path because when the velocity increases, so the velocity have increased, then the filament becomes wavy and irregular. So we cannot observe a straight line path. This state is known as transitional state. So next we'll talk about turbulent flow. If you further increase the velocity, then the waviness and the irregularity of the dye filaments increase and finally diffuses into water. So this type of flow is known as turbulent flow. And now we are going to discuss about the significance of Reynolds number. Reynolds number gives us the information about the type of flow through a pipe as laminar or turbulent or transition. It also helps in solving the problems in fluid mechanics such as head loss in the piping system. And if the value of the Reynolds number is less than 2000, then the flow will be laminar flow. If the value of Reynolds number is in between 2000 to 4000, then the flow is called as transition flow. If the value lies above 4000, then the type of flow is known as turbulent flow. So below we can observe the tabular form which indicates the value of Reynolds number and the type of flow through. Next, we are going to discuss about assumptions of Reynolds number. The assumptions of Reynolds number are ideal and Newtonian fluid, less viscous fluid, and frictional factors. F is equals to 0. So this is all about Reynolds number. I hope you guys understood.